A year ago, I made this simple visualizer. I remember searching tutorials on YouTube because I had no idea on how to make this. The result is a simple circle made out of 512 cubes, each representing a range of frequencies. Then there is a simple particle effect behind, and its speed depends on the amplitude of the low frequencies. So whenever there's a boom boom, it goes faster. At the time, I was pretty proud of me and even released a video on how it works. But I can do better. Way better. Okay, so first let's create a new scene and call it retro, because this will be a retro audio visualizer. Here is how we are going to organize things. We'll have a moving grid underneath the camera, with a sunset at the horizon. The sun will have bands going from the middle to the bottom to give the feeling of heat distorting light. The background will be full of twinkling stars, and on the middle there will be the audio visualizer. It will be a mirrored curve with a shadow behind it. Finally, I'll display the title of the music somewhere on the screen with the name of the artist. First thing we are going to do is to create the grid. I'll add a plane and scale it, and create a new shader graph. We need a grid, so we'll start by adding a rectangle and then tile it. The amount of tiling will be stored in a variable, so we can modify it later. Then, to move the grid, we simply change the offset of the tiling on the y-axis. I'll add some color nodes to let us change the color and the transparency, create a material and a moving grid. Now we'll make the sun. Let's add a circle at the horizon and create a new shader graph. In this one, we need to create bands that are small on the middle of the sun and larger on the bottom. To do that, let's create a rectangle, preceded with a tiling on the x-axis. The problem is that the length of the rectangles is the same everywhere, so we'll need a gradient going from white to black and connect it to the length property. White being a length of 1, while black is a length of 0. So now we can see that everything on the right is black, and then the farther we are on the left, the bigger the rectangles are. We now connect this to the alpha threshold of the shader, so everything white is transparent while everything black is opaque. We just need to add a gradient to color our sun and voila! I'll start adding post-processing effect because this looks a little bit empty. Okay, so gloom, chromatic aberration, grain, color adjustments, and vignette. Whoa, that's better now. Last shader to make, the twinkling stars. For this one, I had no idea on how to start, so I simply followed an online article. I'll link it in the description. Basically, we create a circle and add flare rays to it. This is our star. Then we tile it and offset each star by a random number on the x and y axis, but now the stars are cut off. To correct that, we copy past 9 times the graph and offset it to patch them up. We add some random size to them, random flare size, and add a variable to make them twinkle. Finally, I'll add a bit of colors, and here is the result. Now let's animate things a bit. Because we added variables to the shaders, we can easily modify them with time and adjust the speed. This is nice, but as you can probably see, there's a little flickering on the bands of the sun and on the grid. This is because the lines are small. So on one frame it gets rendered, and on the other it is not, resulting in flickering. To correct that, I modified the sun shader by adding a minimum height value, and I updated the grid shader by only rendering the first lines. This is far better. I think that we are creating a time machine, guys. This looks so retro. Let's now create the curve. I'm going to recycle the spectrum analysis code from the old visualizer, but I'm changing the display. If you want to know how this works, check out my video on the topic. I'm going to do a quick recap here. Basically, the human here can hear from 20 to 16,000 Hz. With a mathematical function called the Fourier transformation, we can get the amplitude of each frequency. However, music's interesting frequencies only goes from 20 to 2000 Hz, so with a simple script, we can zoom on these values and create samples. Then we can simply use the amplitude as the height of the curve. The problem is that it is going to be ugly if we put the raw data into it. What we are going to do instead is to use fewer samples, like 32, and do a cubic interpolation between the heights. I'm not going into details on that, it is a way to connect points together smoothly. Anyway, now we have an array of smoothly interpolated heights. We just have to create a rectangle with many points and change their height on every frame based on the previously calculated data. The result is actually pretty nice already. To have more control over the size of the curve and to make sure it is always fully visible, I added another camera to specifically render it, and stacked it over the main camera. This has the effect of making the curve always render on top of everything else. But also, for some reason, it doubles the post-processing, but that's fine. I'll duplicate the curve, scale it and offset it to make a shadow. I had to do some tricks for the shadow to work, because here we are out of range of the data. So I simply mirrored the curve, and this is barely noticeable, so it's fine. Last thing we got to do, the text. For this, I'm using the Text Mesh Pro package, which gives a full control on the text effect. I downloaded some cool free typos and started making the effect. As a final touch, I made the text glow at random times to emphasize the neon style. And there we go! In this video, we basically created a time machine to go back to the 80s. I had a ton of fun doing this visualizer and I hope that you enjoyed watching the video. If you did, consider subscribing and leaving a comment, it helps me a lot. Thanks for watching.